Right. Good morning again, and welcome to your last math lesson of the first half of second term. I just want to say, I know this is not an easy way to have to actually be able to learn, and I'm very appreciative of the way that you guys have embraced this. I'm very appreciative of the way that you've actually been committed to attending lessons as much as you can. Um, Thanks for letting me know, Matt. I'm sure he'll join us again as soon as possible. So, yeah, guys, Patsimo, we are generating reports for you, okay? And we've been given a deadline date as staff to have marks and comments all ready and everything by the 20th of June. So I'm sure your reports will appear not long after that, probably by the 27th, you can be guaranteed of getting a report. That does mean that after the half term, I do need to give you guys some work that I can mark. I know we've done that one little quiz, okay, but we do need to get some other work as much as possible. We are going to be trying a system to be able to try and get some integrity into our tests and things like that, and that's a website called exam.net. You may have heard it. Your parents might have spoken to you about it already. I know that the school has sent out an email to your parents regarding that. So it's a little bit more reliable. I still need to test it out and see how it's actually going to go in terms of receiving exams and things like that. But I do know that it doesn't allow you to submit anything late. So the Google Docs at the moment, or the Google quizzes and things like that, still allows you to submit things a little bit late. And I do understand that there's a problem with that as well, because some of you do have a slow internet connection, or it drops you every now and then. So these are just little things that I'm still thinking through at the moment, and we'll just see how it goes. So yes, you will be getting a report. That was the long answer. And I do need to do a couple more things with you guys in order to be able to get marks from you. It does mean that some of those might be in the shape of tutorials, so that'll be a bit of revision that you need to do on sections that we've already covered this year, which is actually a good thing, because it won't be long after we get back that you will need to start preparing for trials. And I know that it sounds like September is a long way away, but actually it's not, guys. Okay, it's 3 months away, 3.5 months away. And we do need to start looking towards prepping and planning for those trial exams. Yeah. So, as I said, guys, I'm very grateful and very appreciative for the way that you guys have dealt with this. I'm sure in fact, I know it hasn't been easy. I know it's been a challenge for probably most of you, okay? But from my side, from the teacher's side, I've actually really appreciated and enjoyed the way that you guys have actually knuckled down and just done this and got on with it. So I think if we can continue to do that after the half term break, you guys are certainly going to be in a far better way, or far better prepared than many other pupils around the country. So well done for that. Congratulations for that. And I want to say thank you for that. Okay. Right, guys. You should be seeing my screen at the moment, and on my screen is the question that I left you with on Tuesday. Now, it might have caused some of you a bit of consternation as to actually how to go about that and what to do with that. And the clues that I gave you on Tuesday were probably or possibly meaningless to a number of you. So I want to look at this example, okay, but before I get to this example, I want to deal with a little bit more on limits and how we actually work with limits, and then I'm going to come back to this example again. Okay, so I'm not going to move it from the top of my board. I'm just going to work and do a bit of how we do calculations and limits before I come back and do this. Okay, so we'll ring fence that and we'll come back to that just now. Let's have a look at this example. The limit as x tends to 1 of x squared minus 3. Now, what is this actually meaning? Now, hopefully you can remember from Tuesday that the limit, when we're talking about a limit, okay, we're saying what y value or what value is this whole expression getting closer and closer to as the x value gets closer to 1. Now we're interested in what it gets closer to from both sides, but fortunately we are aware and we know that this is a parabola, and from the demonstrations that we've seen, we know that it's going to come towards the same value. Now in this case, we've got to be very careful. I'm not asking you here for a gradient. Okay, this question I was asking you for a gradient, and that's why we're going to come back to that just now. This here is simply just saying what value does this thing get closer to as x gets closer to 1. Now if we draw this graph, it looks something like that, going through minus 3 over there. I'm not going to worry too much about that, but negative root 3 and root 3 would be the two x-intercepts over there. Now what this question is asking is x equals 1 is over here somewhere. Okay. The value of this expression is read off the y-axis. So your y-axis gives you the value. Now remember, we're talking about a value. We're not talking about the gradient. We're simply just talking about values at the moment. So the y value gives me my value. Let me give you an example. The value of this expression when x is 0 is negative 3. There it is there. When x is 0, the value of that expression is negative 3. Okay. So this is saying or asking what value, what y value is x squared minus 3 getting closer to as x gets closer to 1. Now, fortunately for us, when x is 1, the graph actually exists. We can get a y value. We can find that point over there where x equals 1. And this can happen nice and simply because now we can just substitute the 1 into that. And we get a nice neat answer of negative 2. So the value of this expression, or the value that this expression gets closer and closer and closer to as x gets closer to 1 is negative 2. Okay? Again, we're talking about values. We're not talking about gradients yet. We're going to get into gradients a little bit later. This one was all fine and hunky-dory. This worked out very nicely. I could simply put 1 into there because the graph existed there, and I could find the value. Okay. A limit is not concerned about whether the graph actually exists at the point. It just wants to know what it's getting closer to. So let's have a look at this one over here. And I hope this doesn't throw you too much, the fact that I'm introducing infinity again. What is this asking? This is saying What value does 1 over x get closer to as x gets closer and closer and closer to infinity? Well, let's have a look at what the graph is going to look like. And it's a very simple, straightforward graph. I'm only going to draw part of it. It's the hyperbola. Okay, and we know the hyperbola gets closer and closer and closer to the x-axis as x gets bigger and bigger. And we kind of actually even answered our question by just that statement. Right. X tends to infinity just means x is getting larger and 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 larger. Which means I'm looking at what is happening as x, or as my graph is moving in that direction. And I've answered that question. It gets closer and closer to the x-axis. But the x-axis is not the value. What is the value at the x-axis? The x value at the x-axis, the y value, or the value at the x-axis is y equals 0. We know it'll never get there. Or hopefully we understand that it'll never get there. But as x gets bigger and bigger and bigger, the value of 1 over x continues to get smaller and smaller and smaller, and it will approach 0. So the limit as x tends to infinity of 1 over x is 0. How do I then apply this to my gradient formula? And this is where we're going to come back now and look at our previous example. Before I move on, grade 12s, are there any questions, anything that you're not sure about with respect to these two examples? Okay. Let's come back to this example then. This example wants us to work out the gradient of that function at the point 2, 3. We do know that my exact gradient can be worked out using this formula that we looked at beginning of the week. That's the formula that we worked with at the beginning of the week, or that we got to at the beginning of the week. Hopefully that doesn't seem foreign to you guys. I do understand it's been a while since we looked at this, but hopefully it rings some bells. Okay, this part without the limit is my average gradient. Put the limit in, it now gives me my actual gradient at a point. The problem we have here, we know our x value. X value is 2. So I can substitute my x value and say I'm looking for this. Now I can't just replace my h value for 0 here. Just like we couldn't replace x with infinity, okay, because we can't get there. I know I can get to h being 0, but with h sitting in the denominator of my fraction here, that's going to present a problem. I'm not going to be able to evaluate that while h is sitting at the bottom. So somehow we need to try and work with this so that this h actually goes away. So the first clue that I gave you guys on Tuesday is substitution. Now, what did I mean by substitution? Sorry, this isn't f at x here. Thanks, Rach. I've just picked that up. That should be an f at 2 as well. Right. I can find f at 2. F at 2 is actually very easy. We just put 2 in the place of x. We get 2 squared minus 1, which gives me an answer of 3. This answer of 3, I can now put where I've got f at 2. But what about this f at 2 plus h? All right, now 2 plus f at 2 plus h, what that is actually meaning, or what it's saying we must do, is we must take 2 plus h, the entire expression, and replace it into the x. Okay, so what does this look like algebraically? Well, we've got an x squared minus 1. This is saying replace the x with 2 plus h. So instead of x squared, we must have 2 plus h squared minus 1. This can be simplified, and that was my second clue to you, was simplify. Four plus 4h plus h squared minus 1, which I can simplify even further to h squared plus 4h plus 3. And this whole thing can now go into the place of the f at 2 plus h. So I've now got things that only include h's. So I'm going to carry on working back up there. My limit as h tends to 0 of f at 2 plus h, which we know is this, h squared plus 4h plus 3, minus f at 2. F at 2 is 3. And this is still all over h. I'm still going to carry on with the simplifying, because at the top here, I can see that those parts are actually going to fall away. So I've got the limit as h tends to 0 of h squared plus 4h over h. Now this seems to be a lot of work that we've done to end up with still an h in the denominator. However, we do have an opportunity now to get rid of that h at the bottom. One of the other clues that I gave you was to factorize, which means at the top here, I can take out a common factor of h. And that now actually works out quite nicely, because these h's are now going to disappear. Without the h at the bottom here now, I'm able to substitute my 0 in the place of h, which means here I get an answer of 4. And that is the answer I told you on Tuesday you can expect to get. So if any of you are able to get that answer, well done. As long as your maths was correct, you are superb. Right, any questions here, guys? It's not -3, Nicole. We've got the minus there because of the minus in the formula. There's my formula with the minus there. And we evaluated, in fact, we didn't even need to do this evaluation, but I did it by taking 2 and putting it in the place of x in the given formula, in the given function. The reason why I didn't need to do this calculation is that they'd actually given me the full coordinate. So I would know from this coordinate that when x is 2, the y value is 3. So f at 2, yes, correct, because we have the coordinates. Van, sorry, I'm not quite understanding your question. There's my formula.
Yes, sir. So the one where it says F2, you know, it's under
There.
the, yes, sir, there.
Okay, so I know that f at x is x squared minus 1.
Yes, sir.
If I've got now f at 2, it means I've got to replace the x with a 2 into that formula there. So wherever I see an x, I'm going to replace it with a 2. So f at 2 equals 2 squared minus 1.
Okay, sir. Thank you very much, sir.
Okay, so we're always going to go back to our original function in order to be able to do substitution. Okay, anything else, guys? Okay, I've taken a photograph and I've uploaded a photograph of this exercise onto the classroom for those of you who don't have textbooks with you. And this exercise 8.3 is what you guys are going to be doing. Okay. This question 1, find the limits if they exist. So that's very similar to the 2 examples that I did with you beforehand. You do see in questions G to J, it does get a little bit more complex. In fact, question J is something that we're actually going to examine in detail when we come back from the half-term break next week. Questions G, H, and R, not so much R, but certainly G and H, are the working out that we've just done with this example, or similar. Question I and question J now generalizes it. So instead of having a 1 here and a 2 there, they've called it X's. So they've generalized that whole pattern. And that we're going to look at in a lot more detail when we come back after half term. Okay, it's a process called first principles. And you have to know how to do first principles because you are very likely to get a question in your exams that you will have to use first principles. Right. Then question 2 is like the example that we've just gone through over here. Give you a function and they ask you to find the gradient. So what we've done here by using this formula and then the whole idea of a limit concept in order to evaluate that. One thing I do want to point out here, guys, okay, is question D has x squared minus 2x. In this example that we've done, we only had a single x in our function. So when we did the substitution, we just put the 2 plus h in the place of x. But if there had been another x, I would have put 2 plus h into that x as well. So in this question over here, where it's question 2D, you've got x squared minus 2x plus 3. You are going to substitute your x plus h in the place of x by the x squared. and you're going to substitute it into the x by the 2. Okay. It actually won't be an x plus h, it'll be 0 plus h. But just remember to do it in all instances of x. The question above, question C, doesn't have any x at all. So there's no substitution that's going to take place there because we will only be replacing into x's. Okay. Right. Any questions, guys?